All right, guys. So solving quadratics by graphing. So we talked about finding the the vertex the other day. Couldn't even think. And so we used this formula, which was x equals negative b over 2a. So for this one, b is 4, so it's negative 4 over 2 times 1, because there's a 1 right there. And that's going to give us negative 2. So our x equals negative 2. So this is our vertex. And so if our x equals negative 2, then that means our f of negative 2, which is what we're going to solve with, is negative 2 squared plus 4 times negative 2 plus 3. So when we get this, we get a 4. I'll just go ahead and finish it out. I don't want to make a mistake like I normally do. Negative 2, that's going to be negative 4. This is negative 1. So I have a point of negative 2, go negative 2, and I go down 1. So that's my point right there. Now, this thing is going to make some sort of curve like this. All right? And our solutions, the reason it goes up is because this is positive, A is positive. So our solutions are going to be right here. Those are our solutions. Those are our solutions, which are the same thing as our x-intercepts. So our x-intercepts are solutions, and it says we want to solve the quadratic. So we have to find our solutions. Well, there's a couple of ways to do it, and we're going to do it by graphing, and then next week we'll do it by factoring. So if we're going to do it by graphing, we know that I can start testing numbers on the left and on the right of this thing. So I know that if I did an input-output table, I get x and I get f of x, or this is y. If I plug in negative 2, I get negative 1, and that's my vertex. It's always nice to work with that. And then I'm going to pick a number on the left of negative 2, which the next available number is negative 3. And then I'm going to pick another number on the right, which is going to be negative 1. Okay? So if we have negative 2 here, I pick negative 3, 1 that way, and I pick negative 1, 1 this way. So I go to the left and the right. Now from there, I just work with our math here, and I say, okay, well then, let me do it in green so you guys can see it. I'm going to say f of negative 3 equals negative 3 squared plus 4 times negative 3 plus 3. Now, if we clean this up, we got 9 minus 12 plus 3. That gives us negative 3 plus 3, which gives us 0. So my answer is 0 right there. All right, let's do this next one. I'll go ahead and erase this. When I plug in negative 1, f of negative 1 equals negative 1 squared plus 4 times negative 1 plus 3. I get 1 minus 4 plus 3, which gives me 0. I get 0. So, when y equals 0, I get negative 3. This is the definition. These are the definition of x-intercepts. When y is 0, x has a value. That is the definition of an x-intercept. So if I plug it in and I get a y value of 0, then my solutions to the graph are the x-intercepts. So the answer to this is x equals negative 3 and x equals negative 1. Those are my answers. Why? Because when I plug their values in, I get 0 for a y value, and that is literally the definition of an x-intercept. All right, so that's how you find it by graphing. So we kind of find it by graphing that way. And then, whoops, almost knocks up myself out there. So if we tackle that, what happens when it's not pretty? What happens when it's a little bit uglier and they don't give us a nice problem? So they give us x squared plus 6x plus 6. All right, so let's tackle our vertex here. So we have a vertex of x of the vertex is equal to negative b, negative 6, over b at 2 times 1, which is negative 3. And so our y of the vertex is equal to f of negative 3, which is equal to negative 3 squared plus 6 times negative 3 plus 6. So we get 9. This is going to be minus 18 plus 6. Negative 9 plus 6. And so we get negative 3. So I've got, oops, too much. So with all that work, I know my vertex is at negative 3 and negative 3. That's where my vertex is at. All right, so let's go ahead and graph this thing right now. We know it's at negative 3 here, and negative 3, that's my vertex. We know that it's pointing up. So we're going to go up, we're going to go up. Now we got to figure out where these things are. So we've got to figure out how to find our values here. So I'm going to erase that one on the left here, guys. And we're going to create an input-output table. We're going to go, we got our vertex. Remember, we always want to do our vertex. And this is x and f of x, which is our y value. And our vertex was negative 3 and negative 3. So now I'm just going to go ahead and I'll just start like I normally do. I'm going to pick one to the left. And we're going to have negative 4. And then I'm going to leave a little space there. And then I'm going to pick one to the right, which is going to be negative 2. And I'm going to leave another space there because we may need it. All right, so let's go ahead and start working our math here, working our math magic. So we are f of x is equal to x squared plus 6x plus 6. So if I plug in negative 4, I get f of negative 4. And you can use your calculator for this, guys. Negative 4 squared plus 6 times negative 4 plus 6. All right. So we get 16, negative 24 plus 6. I get negative 8 plus 6. So this is negative 2. So at negative 4, I get negative 2. Uh-oh. Negative 4, so this is here. I get negative 2. I'm not past the x-axis. Remember, we got to get to the x-axis to find the solution. So I'm going to go ahead and say, okay then, I'm going to pick another number. I'm going to pick negative 5. So then I'm going to put negative 5 in. So f of negative 5 is going to equal negative 5 squared plus 6 times negative 5 plus 6. This is going to be 25, whoops, minus 30 plus 1. So negative 5, oops, sorry, plus 6. Negative 5 plus 6 equals 1. So if I go negative 5 and 1, so that's my point there. So this is negative 5 and 1. Okay. So let's go ahead and do the brown one here. And we're going to do negative 2. So let's plug in our negative 2. We get negative 2 squared plus 6 times negative 2 plus 6. Remember, this will take a lot faster if you plug this into your calculator. This is 4 minus 12 plus 6. That means it's negative 8 plus 6, negative 2. So f of negative 2 equals negative 2. So f of negative 2 equals negative 2. Now remember, if you use your law of symmetry, you know that since on the left side, it's negative 2 for the y value, on the right side, it's going to be a negative 2. So if I move over to negative, so that way we've got, I know my graph's a little bit off here, guys. So because they're the same on each side, so the y values are going to be the same on each side. So that means if I plug in negative 1, see this is where properties help you guys move things quicker. If I have negative 1 here, and it's 2 to the right of the axis of symmetry, then it's going to be the same value as this one. So it's up here. Oops, negative 1. Yep, so I got to redraw my graph here a little bit. That's the problem. So we got it here. So, but I don't have an exact value. If we look at this, I don't have an exact value. I don't have an exact value for my x-intercept. My x-intercepts are right here. And if you notice, they're going to be in between, this is going to be positive 1. They're going to be in between these two values. Well, if this is negative 3 and this is negative 4, this is negative 5. Now I want you to notice something. The y value goes from a negative to a positive. Look how a y value is negative to a positive. That means it goes from the bottom of the graph to the top of the graph. This is a negative and it moves to a positive. It goes from the bottom of the graph to the top of the graph. When you see a y value change from negative to positive, your x value, your solution, is in between. So right here, negative to a positive, the solution is in between. Because the graph is traveling from this point to this point, and it crosses in between the negative 4 and the negative 5. It crosses somewhere in between there. So how do we write that by graphing? So we write that by graphing by just saying, so solutions x is between negative 4 and negative 5. Oops, this is negative 5. Use the left, do the left one first. And between negative 2 and negative 1. We don't put equal to signs because we know that they're not equal to negative 2 and it's not equal to negative 1. X is in between there. Okay? So if we take this out, we just put x is equal to this and this. That's our solution. It's somewhere in between those. So when we're dealing with graphing, if you don't find an exact x-intercept, you're gonna state a interval that they're in between. Don't forget, you may have to test a couple of extra numbers. But other than that, there you guys go, solving quadratics by graphing.